Hello guys, welcome back to my channel. So if you are just starting with the data structures, right, and you're in the right place. So today we are going to talk about one of the most simplest yet most powerful data structures. Okay, so it's nothing but stack. You must have already seen the thumbnail, right? So by the end of the video, you will not only understand what is stack, right, how it works and where it is used, and how you think you should think as a programmer. Okay, let's go. So before we touch any code, let's think about sometimes you do what are the things you do every day. Imagine you have a stack of plates in your kitchen. You put one plate on the top, then the another, right? Now when you need to pick a plate from that stack of plates, what you do, you just pick the one which is on the top, right? You actually don't pick the plates which are in the middle of the things, right? So you can't just pull out one out of from the middle. What will happen if you pick it? It will actually mess it, right? That's exactly how a stack works in programming. The last item which you put in, okay, the last item which you put in, will be, so you are going to put the stack items here one by one. So so for example, you place 5, right? So 5 will be placed, it will go into the stack. Okay, you place 10, so 10 will be, so let's take an example here. Okay, now for example, you have something called a stack of 5, 10, 15, 20, and 25, right? What happens here is, first you place 5. Okay, so this will be something called head or top, you call it as top. Okay, you place an item, so that item will be moved to the bottom of the stack, right? So so let's say you put 5, okay, then 10, then 15, then 20, and then 25. Okay, now, so the item which is pushed to the last, right, that will be pulled out or popped out first. So that's why it is called as last in, first out. So technically, what is a stack? A stack is a linear data structures. Okay, it where elements are added and removed from only one end. We can't. You are. I mean, a stack is a linear data structure. What will happen is you add or remove a or remove an element from the one end only. Okay, so for that's why, right? So that's why you add or remove an element from one end. The element which is added in the last will be pushed, I mean, will be popped out at the last, right? So that's why we have two operations in the stack. One is push and the other is pop, right? And it's suppose other two things also, operations, that is called peek. Peek is nothing but the top element. Okay, so array of top is nothing but, that's the, I mean, it's a peak. Okay, and there is one more operation called empty. Empty in the sense, when you don't have any elements in this stack, that is nothing but it's an empty, right? So that's why we have four operations. One is push, pop. That's why we have four operations. Okay, four operations are push, pop, then peak, and the is empty. Okay, now let me show you exactly what happens when actually try to push one by one. Let's say that's what I shown you, right? So we have pushed 5, and then 5 will go to the bottom, right? And then 10 will go here, then 15, then 20, then 25, right? So what will happen? So this is how a stack will be working here. Okay, now now so where this is exactly used? Okay, this is exactly used where, so for example, so once something you added in a document, okay, and you are trying to do control Z. Okay, when you do control Z, the app pops the last item of the stack. That's it. Whatever the stack which is added to the last, it will just pop out that. Okay, I mean, the other thing where it is exactly used in the browser history. So when you hit back the button, right, back button, the browser pops the current page to a stack and shows to the previous one. When you just click the previous button, right? For example, uh, you're in a browser. Okay, you're in a browser. Let's say if I say I say stack, right? Stack implementation as array. So you just go out, right? This is where the stack works here. Okay, and third thing is where we use is when you're working on balancing brackets. Compilers use a stack to check if parentheses and the curly braces are properly matched or not. Okay, this is one of the implementation. Okay, so most properly in our real time example, I have already given you the real time example, right, where you have stack of plates, right? When you place stack of plates in our kitchen, right? So you place plates one by one and you pick the last plate, right? If you pick the any of the plates which is in the middle, what will happen? It will mess up, right? So that's where. So so in Java, generally, how do you write the stack implementation is? Let me show you how you write the stack implementation. Okay. So stack implementation. So first of all, let's check the uh, inbuilt stack, how it is built. Okay. Stack inbuilt, how it is actually built, or we can say stack inbuilt or whatever it is. Okay. We'll see about that stack inbuilt. So how the stack has built internally, and let's see the real-time example of how to implement stack using the array. Okay. Now what will happen is, so if I just say stack, this is the inbuilt Java has given it. Stack is a class. Okay. So stack is a class. So if you check how what stack is implementing, okay, when you click on the stack, so this is actually implementing a class called vector. Okay, internally stack is built on a item called, I mean, it is actually internally built using the arrays itself. Okay, so if you check somewhere here, so if I actually zoom out somewhere here, where is that? So it is internally using arrays itself. Okay, if you check remove element, add element. Okay, so let me show you that one second. So it is internally using stack is internally using arrays itself. Okay, so and it is actually stack is a class which is implementing a class called vector. Okay, this is actually we have already learned this in the our what do you call, we already learned this in the our collection topic, right? So where we actually learned about stack, and I mean we learned about vector also. Okay, if we please go through my collections playlist where we have already learned about this. Okay, so this is the inbuilt stack which Java has provided. Okay, now using this, so if you want to add stack dot push 10, stack dot push, so push 20, stack dot push 30, stack dot push 40. Okay, now if I want to, pop out. Okay, so if I have to pop the, I mean, so what will happen in this case is that when you place 10, right, 10 will be placed here, then 20, then 30, then 40. Now if you pop out, what is the element you're expecting when you pop the element, right? When you pop the element, what element are you expecting? At the top of the element we have something called 40, right? So if I just, so if you check this, uh, if you check the pop, right, it returns integer object. I mean it is actually giving something called a generic thing. Okay, so generic is nothing but, so whatever the elements you add, right, so it will try to convert. So in this case we have added something called integers, right? So it will convert it into integer. So pop top element, let's say it is top element. Okay, so top element, so it's giving object, right? So what we can do is we too can do one thing. Okay, let me actually add just integer. Okay, so we can convert it into an integer. So what happened is we could add a generics here, so that, so it will resolve the problem. So now what happens, so if you try to print this top element, right, so if you check it, it will give us 40. So the element which is added at the last will be popped out first. That's why it is called as last in first out. Last in first out, right? So in this case 40 is the element which is added at the last. That's why this will be popped out first. Okay. Now if I say even the peak, okay, stack dot peak, okay, peak is also nothing but it's a what do you have the top. Now you already popped out 40, right? So in this case 30 will be the top element. So if you check, if I just sys out this, if I just sys out this, what will happen? So it will try to print the 30 as the top estimate because 40 is already popped, right? So it will try to print the 30 as the uh, see, if you just check 30 is the top element. So why? Because you already top popped out the you have popped out the 40 element here, right? That's why 30 is the top element, right? So in this case, top, I mean top peak element is nothing but the top, whatever the value which you have at the top. Okay. So so we have already learned about push, we learned about pop, we learned about peak. Now this is the what do you call inbuilt structure, inbuilt data structure which Stack has provided. Let's try to code how this push is implemented, how this pop is implemented, how this peak is implemented. Let's try to implement our custom stack. Okay, let's say custom stack. How does the custom stack is been implemented? Okay, if you check this custom stack, okay, so how does the custom stack is implemented? So generally we need something called, so if, what you have to do is, you have to define an array. Okay, an array with some size. Okay, so default size, uh, if I say uh, new integer array, for example, if I just want to print this new integer array. Okay, so what how I can do is, if I can give this way, so I have to define some default size. So default size I will give it as 10. Okay, int default size as 5. Okay, I'll give it as 5. So default size is 5. Okay, now, and you have to define something called top. So generally what will happen is, okay, so if I try to show you, so top initially top will be pointing to something called -1. So so this top initially will be pointing to something called -1. So we don't have, so if when top equals to -1, it means that stack is empty, you don't have any elements in the stack. Okay, so if top equals to -1, it means it is empty. Okay, now let me try to define the constructor for this. Okay, so so let me try to define the constructor where, so you say uh, you define top equals to -1. You can define even define this top here. You can initialize the top in the constructor also. So top equals to -1, and you can, what you can do is, you can say array. Okay, this whatever the array which you have defined here, this you can give here also. Okay, okay, you have initialized this here. Fine. Now you have to give some default size, right? That's what I said, default size, int size. So this default size is this size, we'll say it as size. Okay, now you have defined this, right? Now what you want to do, you want to say, now you want to implement something called you want to push the elements, right? You want to push the elements. So you just define a method called push int item, you want to push it. Okay, so when you're trying to push an element inside a stack, right? So what you will do is, you will first increment the top. Okay, you will increment the top. Okay, you will increment the top. It means that initially top was -1. Okay, so initially top is -1, top is equals to -1. Now when you increment it, it will become top plus plus. Top plus plus means, it means that it will become, what it will become, it will become 1 or 0. In this case it will become 0, right? So top is equals to plus plus, and array of array of top is equals to is item. Okay, array of top is equals to item. Okay, so this can be in a short form, this can be written in this way. Okay, this can be written in this way: top plus plus is equals to item. Okay, this complete logic in a short can be written this way. Now when the stack is full, right? Okay, so when stack is full, how do you find out when stack is full? So if your capacity or your default size, or this can, you can size capacity, or your, say this capacity. Okay, so if your capacity, okay, if your capacity is, if top is your, top is equals to capacity minus 1. Okay, so if top is equals to capacity minus 1, right? So let's take this, or let's take this as this way also. Okay, let's remove this and we'll say it as defined as capacity itself. Okay, now when your top is equals to capacity minus 1, you say that this as your stack is full, right? It's a stack is full. Okay, now you want to write something called void pop, right? You want to say pop, you want to print some value, right? So you want to return some value. So pop, what does pop will do? Pop is nothing but array of top. You just return this, you return the top of minus 1. Now when you're returning, there may be a chance, when you're returning, there may be a chance of this stack can be empty, right? So if, so when will be the stack will be empty? Stack will be empty when your top is equals to minus 1. Top is equals to minus 1, because initially top was minus 1, right? Initially top was minus 1. It means that stack was empty, right? So what you say here, if top equals to minus 1, it means that stack is empty. Okay, so stack is empty. Okay, now you wanna, if you wanna get the peak element, right? If you wanna return the peak element, so this is one of the operations or ADT inside the stack. So what do? You just say return of top plus plus. This, I mean, we are trying to return the array of top, right? We are trying to return the array of top. Top element is the peak element, right? So these things we'll try to implement here. Okay, now let's try to uh, okay, what is this? We are saying custom stack. Okay, custom stack equals to new custom stack dot, you say push. I'm pushing 10, then I'm pushing 20. Custom stack dot push 20. So this push method will not call the inbuilt date Java. This will call our whatever we have implemented, right? It will call this. Okay, custom stack dot push 30, custom stack dot push 40. Okay, now if you say custom stack dot pop, right? Pop, pop, you say 4 times. Pop, pop. Okay, you say pop. Okay, so in this case, int, I'll try to add it in sysout. Okay, So this is, so in this case it will give the 40. Okay, let me try to copy this. So in this case it will first it will be 40, 30, 20, 10. And if you try to add now, right? Okay, if you try to pop it, it will say stack is empty. In this case it'll say stack is full. In this case stack is full. Okay, so if I say try to add, okay, maybe I'll try to add one more element. Okay, 60. Okay, so okay, and if in this case if I try to print stack of peak, okay, first let me add peak. Okay, so if you try to print this on the top, right? I just wanted to have this as, okay. So what you have done is, I'm just trying to add, format this. Okay, fine. So what will happen in this case is, what will happen in this case is, so first 10, 20, 30, I mean 40, 50 will be added. Okay, you actually popped 4 times here, right? So if you try to print this, if you can check the console here, okay, you can just check the console. When you check the console, what will happen? 10 is added, 20 is added, 30 is added. Okay, then when 50 is added, after this you check that stack is full. Okay, so if you check, it says array it's out of bound exception. So let's try to, uh, why it is saying stack that way. Let's try to run it again. Let's try to run this. 1 second. Let's try to run this and we'll see why it is giving array rate of wind exception. 1 second. So at what line it is giving 42, right? 42 it is giving 42, 42, 42, 42. This one. Okay, we're getting array in out of bound induction. Okay, length 5, top is equals to capacity minus 1. So we said capacity top is this. Okay, why it is still coming till here? So let's do one thing, let's debug this. Okay, so when you debug this, what is happening here? So your capacity is, you added 10. So first 10 will be added. So you just debug this, what will happen? So first 10 was added, then 20 was added, then 30. Let's debug this. So initially top is minus 1, right? Top is minus 1. So capacity is 5. 5 minus 1, 4, right? So it is not that way. So you made 10 is added. Okay, 10 is added. What happened here? So it's free of top plus plus. Let's do one thing. Okay, now, okay, maybe there is some, so you must have known about this, right? Whether this top plus plus pre-increment and post increment, right? So let's try to check that if whatever the value which we have added, okay, it is working in this way. So first you try to increment the value and then you try to add the, uh, so that's what. Okay, so if you check here, that's what. So what happened here? So let's me try to clear this. So when you try to run this, right? So you added 10, 20, 30. Stack is empty, still we are getting stack is empty, and line number 49 we are getting this. Okay, which, and array end of out of bound exception at the this part. Which part? Top equals to minus 1. Here we can do one thing, one more thing, minus minus. right? So I think uh, that's where actually to try to resolve our problem. So we have added, first we have pushed 10, 20, 30, 40 and 50, right? And then we'll now if you try to add one more element, right? Okay, so at this point of time it says stack is full. Okay, now at the end of the time, now when you try to uh, so I'll show you that also, just give me a couple of minutes. So it still stays at 49, 49, line number 49, it still says that -1. Okay, why is that way? Why it is giving array of bounding exception here? Okay, so we just popped out top is equals to -1. So you just set top minus minus. Okay, so if I try to add one more element here, one more element as 60. Okay, let's first 60, it should give top is full, so it should give stack is full in this case, and it is giving, let's try to check this first part and then we'll go to this part here. Okay, why it is still giving that stack out of bound index of this one? Okay, first let's try to debug this point. So what was happening in this case? Stack is full, right? So index out of bound, one second. So you have added 10, 20, 30, 40, 50, 60, right? You have added all the 5 elements to 6 elements. Okay. Mm, one second. So you've added, pushed all the elements. It should, okay, we are popping. So here itself it is saying stack is full, right? So when you try to add this, that's why it is saying stack is full. Okay. So if you just remove this, what happened? First it, okay, let me try to remove this. Maybe I've added twice. That's why you're getting this. Okay, just remove this. Okay. Okay. Now I'll try to run it now. Okay, so if you try to run this, what will happen? First it will try to prop 50, 40, 30, 20, 10. Okay, and then what will happen? So first of all it try to print the 50, that is peak. Okay, this peak one, and then it will try to print 40, 30, 20 and 10. Okay, 50, 50. Now still we are getting this array index out of one exception on line number 54. Custom stack line number 54, 54. Okay, we are getting array. Okay, here we are getting array index out of bound exception, array of top. So here what we should do is, if it is empty, right, we should return arrays, I mean stack is empty. Okay, this, let's do this. So it will try to it will not try to give that error at the end of the day because stack is empty, right? So let's see that. Line number 32, do we have peak at the bottom also? Okay, that's why it is actually giving that. Okay, let me remove this because we have already popped all the elements, and then we are saying that we were saying that we are trying to print the, we're trying to pop the elements, right? So that's why it's saying you already removed all the elements and trying to peak, you're trying to find out the top, by top is -1, right? So it means that stack is empty, you're trying to print the peak element, which is wrong, right? I hope this is clear, right? So you can just go through again. What we have done here is, push is nothing but, first of all, so what are we doing here? This is nothing but we are incrementing the top, and we are saying array of top is equals to the item which is passed. That is, we pushed 10, right? So 10 will be the array. So initially array top will be -1. Now it will become 1, right? Top will become 1, and then I mean top will become 0. Zeroth element is the 10th. Then next time top will become 2, and array of 1 is 10. Array of 2 is 20, in that way.